You ever notice how your AI assistant, it can talk a really great game about science, right? But when you ask it to actually do science, it just kind of falls flat. I mean, it can describe a medical procedure, sure, but it can't actually go and query a clinical trial database. And that is the exact problem we're digging into today. How to turn that generalist AI into a specialist, a real genius.
Okay, so here's our game plan. First, we're going to talk about AI's big medical blind spot. Then we'll introduce the 869 new skills that totally fix it. We'll get to see the powerful difference these skills make in action, walk through a super quick installation, and then wrap up by talking about the limitations and who this is really for.
Right, so the main issue with a standard AI, fresh out of the box, is that it's like a friend who's read a ton of books. Their knowledge is impressively wide, but it's also pretty shallow. It can spit out text that sounds right, but it can't actually connect to the real-world tools that researchers and doctors use every single day. So just ask yourself this. Can your current AI actually do the work? I mean, can it annotate a genetic variant file, generate a proper SOAP note from patient data, or pull up just the meta-analyses you need from PubMed? For most of us, let's be honest, the answer is a big no. All we get are plausible-sounding descriptions. This slide just nails the problem perfectly. A generic AI? It generates descriptions. A skilled AI? It executes workflows. One gives you believable text about medicine. The other uses actual medical tools to give you structured, real-world data. And that right there is the huge difference between talking about the work and actually doing it. So, how in the world do we bridge that gap? Well, that's where the OpenClaw-Medical-Skills collection comes in. It was created by the team at FreedomIntelligence, and it's this massive, open-source library that's designed to transform OpenClaw from that general assistant into a specialized biomedical research powerhouse. And look, the scale of this upgrade is just massive. We're not talking about a couple of new commands here. This is a library of 869 distinct, highly specialized skills that give the AI brand new capabilities. It really does turn it into a true research assistant. So, what even is a skill in this context? It's actually surprisingly simple, but incredibly powerful. Each one is just a self-contained markdown file, a skill.md file. Think of it like a recipe that tells the AI exactly which tool or API to call, what specific parameters to use, and how to format the results it gets back. It's literally how the AI learns to do things. And those 869 skills cover 5 main areas. You've got clinical skills for documentation, genomics skills for stuff like variant classification, drug discovery for querying chemical databases like Chembl, complex bioinformatics pipelines, and even regulatory skills for things like FDA compliance. It's incredibly comprehensive.
Okay, now let's see how this all comes together to do something really useful. This is the best part, seeing the practical, real-world difference these skills make. We're about to go from just generating text to executing real tools.
This before and after table, it basically says it all. On the left, you've got your generic AI that can only give you vague summaries. But on the right, you have an AI that's executing real queries on PubMed, running bioinformatics pipelines, predicting drug-drug interactions, and generating structured clinical notes. It is a total transformation. Let's kick things off with a classic researcher task, a literature search. You ask your AI to find recent meta-analyses on a specific drug class and outcome. A generic AI would probably just, summarize what it knows about the topic. But with these medical skills installed, OpenClaw does something completely different. It understands what you want. It fires up the PubMed literature search skill, and it queries the actual PubMed database. It comes back not with a summary, but with structured, actionable results, real papers with their PubMed IDs and even their citation counts. Okay, let's try something a bit more specialized, something for a bioinformatician or geneticist. You have a very specific genetic variant, and you need it annotated based on clinical guidelines. And wow, again, the difference is night and day. The AI doesn't just describe the ACMG criteria, it uses the VCF-AMG classifier skill. It identifies the gene, in this case BRCA1, and gives you back a definitive structured classification, pathogenic, class 5, along with the specific criteria it met. This isn't just text, it's a real classified result. All right, for our last example, let's look at a super practical clinical workflow. You give the AI just a few key details from a patient's follow-up visit and ask for a SOAP note. And boom, it delivers.
It uses this SOAP note generator to create this perfectly structured, clinically relevant note, all broken down into subjective, objective, assessment, and plan. I mean, this is a massive time saver, turning a few bits of unstructured data into a formal clinical document. So at this point, you're probably thinking, this has got to be complicated to set up. But the great news is it's incredibly simple. The subtitle here really says it all. It's basically one Git clone to completely upgrade your AI's brain. So this is the absolute fastest way to get all 869 skills. You just clone the repository from GitHub, and then you copy the skills directory into your OpenClaw workspace. And here's the best part. The skills load up on your very next session. You don't even have to restart the OpenClaw service. It's that easy. Now, there are a couple of other ways to do it. If you want a cleaner way to handle updates, you can just point your configuration file directly to the clone directory. Or if you're worried about startup time, or maybe you only need a few specific tools, you can use the ClawHub command line interface to install skills one by one. So you've got options. Of course, with all this new power, it's really important to know the boundaries. The creators are super transparent about the limitations, which is key to using this whole toolset effectively and, more importantly, safely. Okay, first and foremost, and this is super important, this is not a clinical decision support system. It fetches information, but it does not replace a clinician's judgment. Also, you have to be mindful of things like API rate limits from services like PubMed. Some of the more advanced bioinformatics skills require you to have local tools like GATK already installed. And finally, just be aware that loading all 869 skills can slow down that initial startup, especially on an older machine. So who is this for? Well, this collection is an absolute game changer for a few key groups. It's for researchers who are just sick of manually copying and pasting queries all day. It's for developers building new medical apps. It's for clinicians who want a faster way to generate structured notes, and for bioinformaticians who want to automate all those common repetitive lookups. And that really brings us to the final thought here. By turning a general-purpose AI into a specialized tool that can actually run real-world scientific workflows, the possibilities are just immense. So the real question isn't if this is going to be useful, but what specific research, what discovery, what clinical workflow will you accelerate with it?